Can you see the screen now? No. Why? Black. You can't see the screen now? Acha, acha, this. Now it's fine. Okay. So, chalo, we'll start chemical reactions of amines. Write down. Chemical reaction, you write down. Okay. So, the first reaction we have, that is formation of salt. Formation of salt. In this, you see, write down. See, just write down this reaction first. Suppose you have amines, like I'm taking 1 degree amine RNH2 plus HCl. One thing in the reaction of amines you must keep in mind, that this hydrogen which is attached to nitrogen over here, this hydrogen is always most of the time it takes part in the reaction. Okay, so when you keep this in mind, it helps you in memorizing the reaction. Okay, so what happens here, you see this RNH2, right? RNH2, since it is a formation of salt, we have, so here the same kind of reaction is not there, but I'll show you this thing that I told you just now. Here you see this RNH2 will have one lone pair here, right? So this lone pair will take this H plus from this acid, right? And it forms a salt, and that we call it as formation of salt. So that forms like this RNH3 plus, and we have Cl minus. This is the formation of salt we have from 1 degree of amines. Okay, which we also write it as RNH3Cl simply. Okay, now what happens, this if you write, or if I write down like this also, RNH3Cl, this RNH3Cl, from this salt we can easily obtain the amines from which the salt has been formed, and for that purpose we use NaOH, any alkaline solution. Okay, so this what happens in this NaCl forms, H2O also forms, and RNH2 will get into this. So finally we'll get 1 degree amines plus we'll get salt NaCl and plus water releases in this. So that 1 degree amines gives you salt, which on reaction with alkaline solution, right, alkali solution, it forms the amine with which it has been formed, right? But the same thing is not true when we have 2 degree amines. For 2 degree amines, you see the reaction. Suppose we have R2NH. This is 2 degree amine. When it's react with HCl, so this forms the same kind of salt, which is R2NH2 plus Cl minus, or we can write it as R2NH2Cl. Okay. Now for this, when you heat this, it dissociates uh, into the amines, which is the primary amines we have here. RNH2 will get, and plus will get alkyl halide, RCl. Okay, the salt that you get from 2nd degree amine, that is 2 degree amine, on heating that salt we don't get the amine itself, but we'll get 1 degree amine and alkyl halide. This is also the preparation method of 1 degree amine from secondary amine. From first we'll get the salt of it, and then we'll heat this, we'll get 1 degree amines into this. Okay, now the same kind of reaction we have when the amine is 3 degree, tertiary, R3N. R3N reacts with HCl. Okay, so it forms again salt of it, R3NHCl. But when you heat this, since it is tertiary amines, on heating it gives secondary amines, R2NH plus again RCl will get it. Okay, so these are the 3 different types of reaction we have in the formation of salt for amines. One more important reaction here you write down, one note you write down here. 3 degree amine 3-degree amine forms adduct with borane. This is important, okay? 3-degree amine is, suppose we have CH3 whole thrice N. CH3 whole thrice N. When it reacts with borane, BH3, this borane is electron deficient molecule, right? It is electron deficient. Boron has, in this state, boron has 6 electron, hence we call it as electron deficient. And this lone pair of nitrogen, it can donate to the vacant p orbital of boron here, because this boron has one vacant p orbital. So this forms what we say, dative bonding here, B and H3, and this we call it as adduct, ADD UCT. This is the reaction with borane, you must remember. Hmm. 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 Then see, first of all, if you have R dash, two different group we have here, right? So in this, what happens? One of the alkyl group will take this Cl, right, and forms RNH2. So suppose we have CH3, right, and C2H5, CH3 and C2H5. So in this, the see, because this chlorine will be Cl minus, electronegative, right? So this will take the lesser plus I nature, the alkyl group which shows lesser plus I nature. So if you have CH3 and C2H5, it forms CH3 Cl here and C2H5 NH2. Understood? Hmm. And one other thing you see, if correct, CH3 Cl and C2H5 NH2 will get. So lesser plus I will go with halide ion Cl. Okay. Okay. Next, you write down reaction with alkyl halide. Reaction with alkyl halide. I'm just directly giving you the reaction here, okay? Because we have 2-hour, 2.5 hour class only today. So I wanted to finish this, okay? So in this, you see we have RNH2. It simply, primary amines gives you secondary, and secondary gives you tertiary, and then tertiary gives you salt, quaternary ammonia salt, R dash X. So it forms what? HX comes out, like I said, this hydrogen takes part in the reaction. So this hydrogen and X forms HX, and we get R NH R dash plus HX. Again, when this reacts with R dash X again, then again it forms RN R dash 2 plus HX. Okay. Again, when this reacts with R dash X, so we'll get quaternary ammonia salt into this. R N R dash 3 plus X minus. This is quaternary ammonia salt. Okay. Again, whenever amines reacts with alkyl halide, we'll get primary converts into secondaries, then tertiary, and then quaternary ammonia salt. Okay, so this again, it is again the preparation method of secondary amine and tertiary amine, but it is not useful because we are getting mixture of amines into it. Okay. Now, third reaction you write down. Third reaction you write down. Reaction with acid chloride. Reaction with acid chloride. What is acid chloride? We also call it as acylation. acid chloride is this C double bond O Cl, or acid halide is this. What is the suffix for this in nomenclature we use? What is suffix of acid halide? Hmm? Suppose I'll give you this compound. What is the name of this compound? CH3 C double bond O Cl. What is the name of this compound? Hmm? Suffix is oil halide. If halogen is there, general name I'm giving you, it is oil halide. Okay, but since chloride is there, and remember one thing, we start numbering from this carbon here, from the carbon of the functional group. So 2 carbon is there, so we call it as what? Ethanoyl chloride, IUPAC name. Fine. Yes or no? Hmm. Okay, so reaction with acid halide, you see, 1 degree amine like this RNH2. This RNH2, when reacts with suppose Cl C double bond O CH3. Again, like I said, that this hydrogen in this Cl comes out and we get RNH C double bond O CH3 plus HCl. Okay, and the name of this compound is what? What is the name of this compound? N with N alkyl group is attached. So we call it as N alkyl acetamide. Okay, CO, you see, CONH2 is amide, right? CONH2 is amide, with one hydrogen is replaced by alkyl group. So we call it as N-alkyl acetamide. Or if you write down the name here, it will be N-alkyl ethanamide. Understood? 2 degree amine, R2NH. When reacts with Cl, C double bond O, CS3. What we get into this? Again, HCl goes out and we'll get R2N, C double bond O, CS3. What is the name of this compound? Yeah, N comma N dialkyl acetamide. Okay, write down the name N comma N dialkyl acetamide. In all these reactions, you see the hydrogen which is attached with nitrogen here takes part in the reaction, and that is why tertiary amine does not react with acid chloride. Write down. Tertiary amide does not react with acid chloride. Done. Third one. Sorry. Next one you see. Reaction with nitrous acid. Nitrous acid. Nitrous acid is what? HNO2. And how do we get this HNO2? If this NaNO2 reacts with HCl, then NaCl forms and we'll get HNO2 plus NaCl. So in the reaction, they may give you this thing also, NaNO2 plus HCl, or they can give you directly HNO2 also. Okay, any one of these they can give you. So both you have to keep in mind. The reaction is same. Okay. So what happens when this RNH2 reacts with HNO2? This gives you alcohol, N2 gas evolves, and H2O forms into this. Okay, N2 gas evolves, H2O forms into this. You see this HNO2 in this, it exists like NO plus and OH minus. NO plus and OH minus. Okay. Understood? So here you see one thing just which is not important, but I'll tell you here. When you have this RNH2, how this reaction proceeds, that reacts with HNO2. So with this HNO2, what happens? I'll write here NaNO2 and HCl first. This thing. So what happens in this? It forms Rn double bond NCl, right? And this we call it as diazonium salt. Okay, this we call it as diazonium salt. You must have seen this diazonium salt in phenyl. Instead of this R, if you add phenyl ring, benzene ring, you'll get that particular compound only. Okay, and then after this, what happens? This Cl comes out from this, and this bond pair goes here, and we get Rn triple bond N positive charge here. Right now, from this positive charge, when OH minus attacks onto this alkyl group, this bond pair is taken up by this electron deficient nitrogen atom, and we get ROH plus N2. Right? This is how the reaction proceeds. So basically, this is not important. This is not important in this. The only thing you have to keep in mind, whatever R group you are taking here, with that only the alcohol forms. Okay, and in this reaction, hydride and methyl shifting also possible into this. Okay, because you see what happens when this I have written in one single step, but actually what happens, take this bond pair here, and then we'll get positive charge here, where this OH minus attacks. Okay, so I have written it one single step, but actual thing is first this N2 goes out, we'll get positive charge here, and then OH minus attacks. Okay, so this reaction follows actually SN1 type reaction in which the carbocation forms first and then the product we get. Okay, so in this you write down hydride and methyl shifting is possible. Note this point. Hydride and methyl shift is possible into this. Okay, so I'll just write down one reaction here and tell me the product. CH3CH2 CH2 NH2. Now when this reacts with NaNO2 plus HCl, or we can also write down HNO2. What is the product we get here? What? Propane 2-ol. Because here, this is R group, right? R is this only. And we are getting ROH. But when you see, when this reaction proceeds, we'll get positive charge here on this carbon atom. Here you see, we'll get positive charge here, right? So this reaction proceed here. It is not. We should not write down here. But the reaction goes like this: CH3, CH2, CH2, N double bond, NCl. This is what here we have. Now in this, Cl minus goes out and N2 also goes out. So we'll get CH3, CH2, CH2 positive charge here plus N2, right? Now in this what happens? Hydride shift, and when hydride shift takes place, then CH3CH, CH3, and here we have the positive sign, which on reaction with OH minus, it forms CH3CH, OH, CH3. Okay, this is the product. You must remember in this thing that shifting is possible into this. Okay. Hmm. One exception you write down. This reaction is important. Okay. One exception you write down into this. Exception you write down. Methylamine does not give alcohol in this reaction, but forms methyl nitrite or dimethyl ether, but forms methyl nitrite or dimethyl ether. So this is important exception we have. You must keep in mind. So if the reaction is this CH3NH2 plus HNO2, which is nothing but HONO, and on reaction it gives CH3O N double bond O plus N2 plus H2O. Or if you take 2 moles of this CH3 and NH2 plus 2 moles of HONO, it gives CH3OCH3 plus 2N2 plus 3H2. Here we have 2 moles of this. Okay, this is exception you must keep in mind. Experimental thing we have. One more point to write down. Secondary amines forms nitrosoamines, which are yellow liquid and insoluble in water. This is actually a test of amines. Okay, when the amines reacts with HNO2, so primary amine if you have, then in that case nitrogen gas evolves. Okay, that is the test of amines we have. Okay, nitrogen gas evolves. Secondary amines, what happens? They forms nitrosoamines, okay, which are yellow in liquid and insoluble in water. This is the test of secondary amines. Yellow liquid and insoluble in water. Next, write down tertiary amines. Tertiary amines react with nitrous acid to form nitrite salts, which are soluble in water. So these three fact you must keep in mind. Okay, secondary amines forms yellow liquid insoluble. Tertiary amines forms nitrite salt, which are soluble in water. Okay, soluble insoluble you must remember. Next, write down. Next reaction is alkylation. Write down. Aniline reacts with alkyl halide. Aniline reacts with alkyl halide to form secondary and tertiary amines to form secondary and tertiary amines and quaternary salt. Secondary and tertiary amines and quaternary salt. Okay, so the reaction you write down C6H5NH2 plus CH3I. What happens? Hi forms and we'll get C6H5NH CH3. This is what 2-degree amine. When this further reacts with CH3I, so this forms C6H5NCH3 whole twice. This is tertiary amine, 3-degree. And when this again reacts with CH3I, then it forms C6H5NCH3 whole thrice plus I minus. This we call it as quaternary anilinium salt. Anilinium salt. One important reaction we have, which we'll see later on also in the reaction of aniline, we'll see few reactions. This is aniline, NH2. When this reacts with aryl halide, which is Cl, in presence of CuCl, 200 degrees Celsius we are heating. Now in this the product will be this HCl goes out and we get diphenyl amine. Understood? Okay. In this only you write down the next one, that is acylation. This is the same reaction. Okay, so that's why we are moving fast over here. This is the same type of reaction, acylation, in which acyl halide reacts, okay, with aniline. So in this only the second part of this you write down acylation. Acylation means if you have again aniline like C6H5NH2 plus Cl C double bond O CH3. Now this acylation reaction takes place in presence of pyridine. Generally we'll take pyridine, or we can take NaOH also. Pyridine or NaOH. Again HCl goes out into this same reaction. Here you see HCl goes out and we'll get C6H5NH C double bond O CH3. N-phenyl acetamide. Correct? N-phenyl acetamide. Just a second. Okay, next write down test of amines. One test of nitrous acid test that we have already done. Okay. Test of amines. This you have to again memorize. First one is Hinsberg method. Hinsberg method. Write down. It involves the reaction of amines. It involves the reaction of amines with Hinsberg reagent. Hinsberg reagent, which is nothing but C6H5SO2Cl. C6H5SO2Cl. Okay, this is Hinsberg reagent. This you must remember. Okay. Sometimes they ask what is Hinsberg reagent. Not in JE, other exams. Right, on primary amines on reaction with primary amines on reaction with benzene sulfonyl chloride. This C6H5SO2Cl is benzene sulfonyl chloride, Hinsberg reagent. Sulfonyl chloride. Primary amines on reaction with benzene sulfonyl chloride forms N-alkyl benzene sulfonamide. Forms N-alkyl benzene sulfonamide, which on treatment with alkali, solution forms soluble alkali salt. Forms soluble alkali salt. Now you see, suppose I am taking 1 degree amine. This is the test of this. 1 degree amine is RNH2. When it reacts with benzene sulfonyl chloride C6H5SO2Cl. Can you tell me what is the product we get here? Guess. HCl goes out. No, this H and Cl. This HCl goes out and it forms what? C6H5SO2NHR. This we call it as N-alkyl benzene sulfonamide. Okay, it's the N-alkyl benzene sulfonamide. Now, when this salt you put into any alkali solution, suppose KOH, right? So what happens? R H2O forms into this. Again, this H and OH minus forms H2O, and we'll get C6H5SO2 N R and K, potassium. This salt, potassium salt, this is soluble, and this is what the test of 1 degree amine. You'll get soluble salt. It confirms it is 1 degree amine. Okay, this is also soluble in water. This salt is insoluble. Right. So soluble amines reacts with this, gets insoluble product, and again when you reacts with KOH, it gets soluble. Right. This is for tertiary amine. Remember one thing here. This is for primary amine. Second reaction, you see, this reaction takes place because of what? This hydrogen, yes or no? Yes. Yeah. So when you take secondary amines here, then what happens? Test of secondary amines is what? You take secondary amine, that is R2NH, reacts with C6H5SO2Cl. So what it forms? It forms R2N R2N O2S C6H5, right? And N dialkyl benzene sulfonamide, correct? So this is again soluble. This becomes insoluble, and when you put into any alkali solution, suppose KOH, since this N does not contain any hydrogen here, so this does not give any reactions. No reaction will have here. Confirms the presence of secondary amines. Understood? All these reactions, you see whether it is first reaction or second reaction. All these reaction takes place because of this hydrogen. Okay, this hydrogen or this hydrogen. Tertiary amine, if you see, tertiary amine, what happens with tertiary amine? Tertiary amine does not give this reaction, does not give this test, right now. Tertiary amine does not react at all. Okay, next to write down the second test. Yes. Hmm. See, see, one thing is there that you cannot take the mixture of. See, you cannot differentiate. Suppose if you take a mixture of all three kind of amines, right? And when the reaction takes place, then you will get. Then you cannot actually differentiate. That is not at all, that is pointless when you take a mixture of alkenes, when mixture of amines, because 1 degree amines will react completely, right? Soluble, insoluble, insoluble. Secondary amines forms only insoluble salt. Tertiary amine does not react at all. So in that mixture, all three kinds of reaction will be there. We'll have soluble salt, we'll have insoluble salt, and there are few amines which does not react at all. So the point eventually comes that how do you differentiate that which one is reacting, which one is not reacting? Understood? So so this kind of reaction goes like this. I'll give you one particular compound, and we know that this is amines. Okay, and we do not know whether it is 1 degree, 2 degree, or 3 degree amines. And then we'll perform the reaction. Okay. Mixture of amines, if you take, you won't get anything. Like you cannot actually say that whether we have 1 degree, 2 degree, or 3 degree amines, because all three kinds of reaction possible. Okay, so eventually you cannot differentiate. Okay, that's the thing. That's why we do not take any mixture of amines for this kind of reaction. We'll take one by one. Okay, and then we try to do this reaction, and according to the observation, we say the compound is 1 degree, 2 degree, or 3 degree. Understood? Yes. Okay, carbyl amine reaction. Next one. Write down, this reaction is used for the detection of primary amines. This question they have asked. Okay. Carbyl amine reaction is used only for primary amines. Secondary and tertiary amine does not give this reaction. Secondary and tertiary amine does not give this reaction. Next line. Primary amines on reaction with chloroform in presence of primary amines on reaction with chloroform in presence of alcoholic KOH, in presence of alcoholic KOH, forms isocyanides. Isocyanides, which is nothing but carbylamine. Carbylamine and isocyanides are same thing. Okay, forms isocyanide. So now you see the reaction here. We have 1-degree amine, that is RNH2, reacts with chloroform. The formula is CHCl3 plus KOH, and this is alcoholic KOH. 3 moles of this. This gives isocyanide, that is RNC plus 3 KCl, and plus we'll get 3H2. This is alkyl isocyanides. Isocyanides, which has a very bad smell. That only confirms the presence of primary amines. This bad smell. Okay. This isocyanides, we also call it as carbylamine. That's why it is carbylamine reaction. Okay. Third one, that is just to write down the name, we have done this. Lieberman, Lieber, Lieberman nitroso reaction. Nitroso reaction. This involves the reaction with the same reagent that I told you, NaNO2 plus HCl, which gives HNO2 plus NaCl. Okay, and this we have already done. So that is only reaction we have here. So we are not doing the thing again. Okay. Next, write down the last test we have. That is Hoffman mustard oil test. Mustard oil test. Suppose you are taking 1-degree amines in this. Suppose we have 1-degree amine RNH2, and in this test, it is allowed to react with carbon disulfide, which is C double bond S double bond S, CS2, carbon disulfide. And in this, we get first RNH, H, positive sign here, C, S minus double bond S. Actually, this lone pairs attacks onto this carbon atom, and this pi electron goes here. Okay. Now what happens in this? In this, proton exchange takes place. So write down here, proton exchange. One of this hydrogen comes over here. So we'll get RNH, C double bond S double bond S. Double bond SH also. Just a second, wait. Or we should not have double bond here. This is single bond only. Okay, SH. Fine now. Now, when this actually bond pair goes here, so that neutralizes the positive charge. The final step will allow this to react with HgCl2, and the product we get here is Rn double bond C double bond S plus Hg S plus 2HCl. This we call it as isothiocyanate. Isothiocyanate. And the smell of this isothiocyanate is pungent smell. Pungent, or we also call it as mustard oil smell. Mustard oil. And that's why we are calling it as mustard oil test. Okay. Now here you see this hydrogen will take this Cl. So secondary amines, this is for 1 degree amine, you write down. For secondary amine, you see if you have R2NH reacts with CS2, in short I'm writing down now, it will be RNCSH double bond S, and here we have R. After this, when you put HgCl2, then there will be no reaction since nitrogen does not contain any hydrogen here. Okay. Now for tertiary amines, the first reaction does not take place at all. Plus CS2, this has no reaction. Tertiary amine generally does not react. Okay. So these are the test of amines. Now you see we have done like most of the reaction, but there are few reactions which I give you directly. You should know the product into that. Okay, the various reactions of aniline and what product we get. There is no mechanism at all. It is not required, but it is again based on the electrophilic aromatic substitution reaction. Okay, so that mechanism will not do. Few reactions which you need to memorize is this. Write down reaction with Grignard reagent. Write down aniline forms alkane with Grignard reagent. Aniline forms alkane with Grignard reagent. Reaction you see C6H5NH2 plus CH3MgI, that gives CH4. You see, the alkane forms from the alkyl group of Grignard reagent, that you must remember. CH4 plus Mgi, and then we have NHC6H5 NH. So this is the alkane we get that we form from the alkyl group of Grignard reagent. Okay. Oxidation. Oxidation of aniline. You write down as it is. I am writing down. Okay, I'll just give you this table. In this, the reaction I'll give you. So we have NH2 here, aniline. Okay. So for oxidation, we can use different oxidizing agent, and we'll get different product also in all these cases. Okay. Aniline when reacts with acidified KMnO4 or with Na2Cr2O7 plus CuSO4 plus dilute acid. Dilute acid. When these reagent you use, you will get aniline only in this reaction, but it will be aniline black, means the color will be black. Aniline black we also call it as simply aniline black. Aniline, Line, aniline black. Okay. When you use alkaline KMnO4, this you have to memorize all this reaction. Alkaline KMnO4, you'll get azobenzene. This one is important. Azobenzene is this. We have a benzene ring that is C6H5 and double bond NC6H5. Two phenyl group attached with this N double bond N. This is azobenzene. 2 moles of this we are using. Okay, so the reaction is not balanced product, you must remember. When we use chromic acid, what is chromic acid? H2CrO4, right? Or we also write it as Na2Cr2O7 plus concentrated H2SO4. Concentrated H2SO4. In this, we'll get parabenzoquinone. Parabenzoquinone. The structure is this. Oh, sorry. Just a second. Parabenzoquinone is this. Here we have double bond. Here we have double bond. And here double bond O and double bond O. This is parabenzoquinone. Okay. Next we have sodium hypochlorite. Sodium, this one is not important, just to write down here this also. Sodium hypochlorite or HOCl. Here we get para-aminophenol. Para-aminophenol. Okay. And that structure we can draw easily. We have phenol, and at para position we have NH2 group. OH. Carous acid. What is the formula of carous acid? That is H2SO5. Carous acid. When it reacts with carous acid, we'll get nitrobenzene. This one is important. Nitrobenzene and nitrosobenzene. Mixture of this. Nitrosobenzene is C6H5NO. And nitrobenzene is C6H5NO2. With bleaching powder, it gives deep violet color. Not important. Deep violet color. That is it. These are the few oxidation reaction of aniline in which we are using different reagent and we'll get different product. Done. Ramcharan. Okay. Write down next. Benzene diazonium chloride. Benzene diazonium chloride and its reaction. This reaction again you have to memorize. Write down the reagent we use. This actually benzene, write down first line here. Benzene diazonium chloride we can obtain or we can prepare with the help of aniline. Benzene diazonium chloride we can prepare with the help of aniline. And then the reagent you write down in this, the reagent we use for the preparation of this from aniline is NaNO2 plus HCl. NaNO2 is sodium nitrite. Sodium nitrite plus HCl, or we also simply write HNO2 because when these two reacts, it forms nitrous acid and NaCl goes out into this. Okay, so reaction here you see we have aniline, that is 6H5NH2 reacts with NaNO2. Just a second. Okay, let me put it in charge. Okay, NaNO2 plus HCl. HCl in excess. And this reaction usually takes place at very low temperature, around 0 to 5 degrees Celsius. The product we get here is benzene diazonium chloride, which is ring N double bond NCl plus H2O goes out and NaCl forms. Now, to understand this reaction, you see, first of all, this aniline, that is R6H5NH2, reacts with HCl. What it forms? Can you tell me? We have done this reaction. It forms salt, right? Yes or no? We'll get a salt here first, which is NH3 plus and Cl minus. Now, this salt you see, I'll just write down the reaction like this. N with 3 hydrogen and 1 chlorine plus this reacts with O double bond N and OH. Just a second. Haji sir. क्या है? हाँ हेलो. क्या है उधर? क्या? कोई खास है? क्या है उधर? हेलो. हाँ ऑनलाइन क्लास बोलिए ना. क्या है उधर? मामला क्या है? अगर तो नहीं है पापा तो साढ़े है ना पास. आप लेके आइए. और वहाँ पे तो कौन लोग आ रहे हैं वहाँ से? Yeah. तो ये जो हम लोग ये एनपीएस वही प्रॉब्लम है सॉल्व करना है Okay. So when these two react, okay, so you see easily in this reaction, you can understand that this three hydrogen we have here, this hydrogen and this OH and O combines together. So this forms H2O and this forms H2O, right? So we'll get 2 moles of H2O from this, and the product we get here is diazonium chloride and double bond NCl, right? This particular compound, we also write it as like this. Both has actually same thing. N triple bond N plus Cl like this. Cl minus diazonium chloride. Salt it is. So we like to take this also. Okay, done. Okay. Now, few reactions of diazonium chloride, which is again important. Okay, they directly ask this question: what is the product we get into this particular reaction? Okay, so a few reactions we have which are important, and that we'll see. Reaction of diazonium chloride. So I'll write down same as we have done just now. So I'll write down here diazonium chloride, that is plus Cl minus. First reaction you see when this diazonium chloride reacts with HX, hydrogen halide. Okay, and this X can be chlorine or bromine. Generally, we'll take chlorine or bromine, right? And the product we get here is aryl halide. That is a ring and X, aryl halide here. When you take this as CuCN here, right? Or we can also write it as copper in presence of potassium cyanide, right? Both are same thing actually. You'll get this. I'll write down the ring now like this here and CN here. Now these two reactions, we call it as Sandmeier's reaction. Okay, Sandmeier's reaction. When this reacts with Ki, when you heat with this Ki solution, will get again aryl iodide, I here. Okay, very simple, straightforward reactions we have. HbF4. For HbF4, we use and we'll get this. See, these four are important here. For chlorine, for aryl chloride and aryl bromide, we can directly use HCl and HBr. For iodide, we'll get Ki. For fluorine, we'll get HbF4. For this also, we have one reason. Okay, fluorine is most electronegative. That's why we cannot use this here in HX or with this Ki and Kf, right? So we use with this fluoride of boron. Okay, boron hydrofluoride we also call it as. HbF4 is the reagent we use for the preparation of aryl fluoride. Okay, that is again important. When you use copper with HX and when you heat this, where this X is again chlorine or bromine. So we'll again get aryl halide X. Okay, this reaction we call it as Gattermann reaction. Gattermann reaction. When you use this H2 with SnCl2, sorry, SnCl2 and HCl. So here we get phenylhydrazine, NH2. This is phenylhydrazine. With benzene itself, C6H6 and NaOH, will get this as the product, C6H5. Okay, this reaction we call it as Gomberg reaction. This one is not that important, just to write down. With NaNO2, we heat this and we also use CuO2 here. Cu2O, sorry. We'll get nitrobenzene. Okay, and the last one more reaction with this I'll write down here. Any acid hydrolysis, if you do H plus H2O, then you will get phenol OH here. And in all these reactions, N2 comes out. Nitrogen gas evolves in this reaction. Okay, so these are the few reactions of diazonium chloride, which is important. Done. Just a second. We have one coupling reaction is there. Okay, write down. Next, coupling reaction of this. Coupling reaction of diazonium chloride. Yeah. Yeah, we'll finish this in few. What is that? This is by 5:15. No, we'll finish this by 6:15, 6:20. Okay. So last half an hour, 40 minutes, we'll have problem solving. Okay. Okay. Next, write on coupling reaction. Only two reactions we have into this. We have diazonium chloride, N2 plus Cl minus. And when this reacts with phenol, right? So phenol in basic medium, the pH generally for this medium will be 9 to 10. Okay, basic medium. Then coupling takes place. Okay, this two joins. What happens? This hydrogen, this Cl comes out. Okay, and the product we get here is this N double bond N OH. This is the product we get. Coupling reaction plus HCl comes out into this. What happens if we take here aniline, NH2? This reaction takes place in acidic medium. Okay, here we get what? The same kind of reaction, N double bond N, HCl goes out and we'll get NH2 here. Okay. Done. Next, write down electrophilic substitution reaction for aniline. Electrophilic substitution reaction for aniline. Write down the first one, that is halogenation. Halogenation. Write down chloride, write down chlorine and bromine water. Chlorine and bromine water reacts radially with chlorine and bromine water reacts readily with aniline and forms trichloro and tribromobenzene. Trichloro and tribromobenzene. So if you have aniline, NH2 reacts with 3Br2, and this we use in glacial lactic acid. Which is nothing but dry carboxylic acid. We have glacial lactic acid. Then we'll get 2,4,6 tribrom. What I told you, 2,4,6 tribromobenzene. What I told you, 2,4,6 tribromobenzene or what? Aniline. Hello? Yeah. Where were you? What I told you, 2,4,6 tribromobenzene or tribromoaniline? Hello? Aniline, no, correct. 2,4,6 tri. What happened? Ask him, text him. Where were you? Kondanya? Okay. Anyways, so Okay, so this is the reaction we have. NH3, this is important reaction. That's why I'm giving you. One more reaction I'll give after this. We'll get different product into that. One note you write down into this. Simply aniline if you are using, then we are getting 2,4,6 tribromoaniline. Okay. After this one reaction I'll give you. First you write down one note. In chlorination, write down in chlorination, water-free solvent such as in chlorination, water-free solvent such as chloroform should be used. Otherwise, oxidation takes place. Okay, aniline will get oxidized then if water will be present over there. So in case of chlorination, we use chloroform, water-free solvent. Okay, that is one important thing that you must keep in mind. Otherwise, oxidation takes place. Okay, next, write down next line. Note I have finished. Next line, write down monochloro or monobromo derivative, monochloro or monobromo derivative of aniline can be prepared if NH2 group is first preserved by acetylation. If NH2 group is first preserved by acetylation, on account of oxidation of NH2. Okay, so what happens, you see a little bit of difference we have and we'll get different, simply different product. If you have aniline, if you do direct bromination of this, then we'll get 2,4,6 tribromoaniline, right? But when you have to form monobromo derivative or monochloro derivative, then first of all, you have to preserve this NH2 group to get oxidized. And for that purpose, we use acetyl chloride here. CS3COCl we can use, or we can also use anhydride, CS3CO whole twice O, right? So when you use this, the product that you get here will be NH, then we have C double bond O, CS3, right? Correct? Yeah. If you use CS3COCl, then another product will be HCl. If you use this, then another product will be CS3COOH. Fine. Right? Now, because of this C double bond O group here, electron withdrawing group, the oxidation of this part is difficult now. That is what we use for to preserve the oxidation of NH2. Now, this what we do, this we allow to react with, suppose bromo derivative product we have to form. So this will allow to react with Br2 with CS3COOH, carboxylic acid. Then we'll get what? Ortho and para substituted product. So this position, we have the same product, that is NHCOCS3, and here we'll get bromine plus para substituted bromine will get here, which is nothing but NHCOCS3 and bromine here. Now in this reaction, this product allowed to acidic hydrolysis, right? Then H plus will attach onto this nitrogen and this group will come out as it is, right? So we'll get here, the product that we get here is NH2. We get here is NH2 Br plus again we get NH2 and Br. This is what the product we have. So if we have to form monoderivative product, right, monobromo or monochloro derivative product, then first we have to preserve the oxidation of NH2, and that we can do by acetylation or by reaction with anhydride. Understood? Para will be the major product into this. This one is the major product. Done? Okay. One note you write down, halogenation of aniline. Halogenation of aniline is faster in polar solvent and slower in non-polar solvent. Faster in polar solvent and slower in non-polar solvent. Sulfonation. Second one. Write down the reaction. NH2 plus H2SO4 giving sulfuric acid. Conc also we can use, and we'll get para substituted product as the major product here. NH2 and SO3H here. This we call it as sulfanilic acid. Nilic acid. Third one is nitration. This is also the same reaction as we have done for halogenation. NH2. First of all, we use CH3COCl, or we can use CH3C whole twice O, and the product we get is NHCOCH3. And when this reacts with conc HNO3 and conc H2SO4, both are concentrated. See, if you use this directly, okay, then we'll get 2,4,6 trinitroaniline. NO2, NO2, NO2 will have here. But when we preserve this NH here, NH2 here, then we'll get ortho and para substituted product. That will be NHCOCH3, NO2 plus para substituted product, which is NHCOCH3, NO2. This one is the major product we have. Now, when you do the acid hydrolysis of this H plus H2O, you will get para-nitroaniline and ortho-nitroaniline. NH2 here, NO2 plus, you'll get here NO2 and NH2. Para will be the major one. Okay, these are a few important reaction of aniline. Next, write down basicity of aniline. Done. Okay, write down basicity of aniline. See, aniline is benzene ring with NH2. So basicity is what? Tendency to lose electron, right? So any electron withdrawing group, if it is attached onto this ring, so any electron withdrawing group, that will decrease the basicity, right? Yes or no? Because electron withdrawing group will withdraw electron, and then tendency to lose lone pair of electron will be less. Correct? And any electron releasing group will be directly proportional to the basicity. Fine or not? So if I write down few examples, say we have NH2, then we have NH2, NO2, NH2, NO2, and the last one we have NH2, NO2. Tell me the basicity order of this. Second one, NH2, and then we have NH2CH3, NH2CH3, CH3. What is the basicity order? Yes, first one is right. What about the second one? Hmm. Okay. See, the first one is correct. The order is this. Because NO2 are what? NO2 are electron withdrawing group, EWG. EWG, right? These are electron withdrawing group. So electron withdrawing group will decrease the basicity. Fine. So obviously this aniline is the most basic. Then we have meta, then we have para, and then we have ortho. Because the meta position will have the least effect onto this. Because NH2 is what? NH2 is ortho para directing group. Yes or no? NH2 is ortho para directing group. So any group that is attached to ortho or para position, the effect of that group will be more. Whether it is decreasing basicity effect or increasing in basicity effect, whatever it is. But the effect will be more when it is at ortho and para position. But that is also not exactly true, because this is what here when ortho position is there will have ortho effect takes place. Okay, so because of ortho effect, the basicity of aniline decreases regardless of the fact whatever the nature of this compound we have, whatever the nature of this group we have, whether it is electron releasing or electron withdrawing. So one note you write down first, you must keep this in mind, that ortho substituted aniline, ortho substituted aniline are weaker base are weaker base than aniline itself, regardless of the nature. In bracket you write down after nature, regardless of the nature, in bracket you write down EWG or ERG, regardless of the nature, EWG, ERG of the group. This is known as ortho effect. This is known as ortho effect. Understood? So because of ortho effect, ortho substituted aniline is always weak base, right? So here in this case you see CS3 are electron releasing group. So electron releasing group will obviously increase the basicity of aniline. But this one is ortho substituted. So this one is the least basic. Fourth one is this, right? Obviously, these two have electron releasing group attached with it. And we know electron releasing group increases the basicity of aniline. So obviously these two will be at first and second position. This will be third. Yes, and this one will have what? Plus I effect we have to see. So plus I effect is maximum for CS3 is electron releasing, right? So we have at two position, meta and para position. Okay, fine. It's your ortho para directing group, no? NH2 is the ortho para directing group, obviously. So this first one will be this, second one will be this, third is this, and fourth will be this. Right? Para substituted aniline. If the substitution is electron releasing group, substituted group is electron releasing group, then that will be most basic. Understood? Yes. Okay. One more point you write down here. Aniline are also weaker base than amines. Anilines are also weaker base than aliphatic amines due to resonance. Few more example you see. Just two more. Tell me the order. Three greater than two greater than one. Why, Kondanya? No, we are talking about the basic nature. Yeah. Okay, so this will be because these group are what? These group are having plus I nature. Because of plus I nature, electron density here increases, and hence the density to donate electron will be more. So order will be this. Similarly for this one. One greater than two. How it is one greater than two? First of all, these CCS5 are what? Electron releasing, electron withdrawing group, right? These are electron withdrawing group. Electron withdrawing group. Okay. So obviously, the electron density on nitrogen decreases. So obviously, the first one will be this. Second one will be this because only one CCS5, and third one will be this. Understood? Yes. Okay. Now, last two things we'll see. The last two things of this chapter. See, there are few reactions of isocyanides and cyanides. Okay, the very important reaction of isocyanides and cyanides that we have that I give you. Okay, other reactions you can go through in the book. Okay, suppose you have isocyanides is RNC, right? RNC. This is isocyanides. When you do the acidic hydrolysis of this RNC isocyanides, then it forms amines, 1-degree amine. RNH2 plus HCOOH. When you take isocyanides, if you take cyanides, that is RCN, and when you do the hydrolysis of this, I'll write down H2O in alkaline H2O2, it gives you RCONH2 first, acetamide, amide you get first, and then if you do the acidic hydrolysis of this, you will get acid RCOH plus NH3. So you see two difference we have here. Ammonia gas evolves, acid forms, and here amines we get into this. Isocyanides gives you amines, cyanide gives you acid. That is one important reaction we have that you must remember. Okay. Reduction you see. Isocyanide reduction. Rn double bond C plus hydrogen. And for reduction we use Na with C2H5OH. Under reduction with nickel platinum catalyst we can use. It gives RNHCH3. 2-degree amine we get here. But if you have cyanides, RCN, and when you do the reduction of this with LiAlH4, you get 1-degree amine, RNH2. So there's a few difference we have. Those are important, and question has been asked on these two. Okay, there are some more reactions of cyanide and isocyanides are given in the book that you can go through, but those are not that much important. Okay, so this is it for amines chapter. Now, what do you want to solve? Did you revise ionic? Okay. Any 11th chapter you want? Okay. Just a second. Okay. See this question. You have to find out the final product in this. Okay. We have phenol, which reacts with CHCl3KOH, which gives A, and then 50% KOH, B. What is A and B? Or if only B, you tell me. Yeah, we have final product. Hmm. These are the options. Option D. What about you, Contania? Why? See, first of all, phenol reacts with CHCl3 and KOH. Okay. When phenol reacts with chloroform with KOH, it gives salicyl aldehyde. Okay. So the first product A that you get here will be this OH here and CHO. This is the product A. And when this aldehyde goes under 50% KOH solution, then this reaction we call it as what? Cannizzaro reaction. Right? So for Cannizzaro reaction, oxidation and reduction takes place, right? Disproportionation reaction it is. This CHO will get oxidized first and then will get reduced also. So one product will be COH here, other will be salt of this COK. So product will be this. Aldol condensation we use 50% NaOH. But for that the condition is we have alpha hydrogen required. Alpha hydrogen condition is there. So this is Cannizzaro reaction. Okay, so this gives you oxidation and reduction of the same compound. Okay, 2 moles of this will take if you remember. If you don't remember, then revise this reaction. Okay, 2 moles of this reagent we take, 1 mole will get oxidized, other one will get reduced. So oxidized gives you salt of this, and reduction gives you alcohol. Fine. Yes or no? Another one. C6H6 H2SO4 350 Kelvin A. Then fusion with alkali B. Then bromine water BrH2O C. What is the final product C? 3 options are given. C. Orthobromophenol, parabromophenol, metabromophenol, and last one is 2,4,6 tribromophenol. Ortho, para, meta, and tribromo. Two four six tribromophenol. Yeah, it's correct. Done. First of all, first product what we get? Benzene sulfonic acid. A will be what? Benzene when reacts with concentrated H2SO4 will get SO3H here. Benzene sulfonic acid. And when it reacts with alkali solution, right? NaOH means what? Fusion when takes place, it means we are taking NaOH with H plus H2O. And this gives you H2SO4 comes out into this and will get phenol in this product. H2SO4 will go out and will take phenol into this. Okay. Now when phenol this reacts with Br2 and H2O, then all these Br will attach here, here, and here. 2,4,6 tribromophenol. These are direct questions. Understood? Acidity, what happens, Ramcharan? Of ortho, para, and meta nitrophenol. You tell me acidity order of this. Ortho, para, and meta nitrophenol. Para. Okay, tell me first one thing. Just a second. You are saying this. Kondania, what is your answer? Ortho, para, then ortho, and then meta. What about yours, Ramcharan? Ortho, then para, and then meta. Okay. You see, nitrophenol is this. And we know NO2 group is what? NO2 group is the electron withdrawing group. An electron withdrawing group increases the acidity of phenol. Yes. So now here you see the effect of NO2 will be more when it is placed at ortho and para position. Fine. Because this group is again what? Ortho para directing. Yes. Effect of NO2 will be more when it is placed at ortho and para position. So meta position will be least acidic, that is for sure. Yes or no? So this is correct. Right. But when NO2 is placed at ortho position, there will be intramolecular hydrogen bonding here. So because of intramolecular hydrogen bonding, its acidity decreases a bit. Okay, so here the para becomes more acidic than ortho. So correct order will be this. Yes, para is not always more stable. In case of amines reaction, para is more stable. The other reaction you'll see ortho is also more stable according to the product. What? Tell me. Okay, so just a second. Hmm, this one I've given you. Next is okay. One more question you see: strength of acid. BitSat. This question has been asked in BitSat. First, we have phenol. And the next one we have OH here and CS3. OH, NO2, NO2, and then we have OH, NO2. Acidity order. What about you, Kondanya? Hmm. 3412. Why so? Hmm. Hmm. Yeah, correct. So correct order will be 3, 4, 1, and then 2. Correct. Now, next question I am sending you on WhatsApp. Okay, because I have to write down so much then. Okay. So I'm sending you on WhatsApp. You just see that question and tell me the answer. This question was asked in JEE Advance. Hmm. No structural change is made to X. Read the question properly, Kondanya. Why A? First, you tell me in which of these, you know, how this reaction takes place. Can you tell me that? That compound which is given with acid, with presence of acid, how this reaction goes. Why so? Which is not released. That is what. See, if you try to understand the mechanism of reaction in this, how reaction may go, then probably you can answer this question. See, we have acid, right? So what does this acid do? It produces what? H plus. So that H plus is taken up by the oxygen which is there in the ether OR that we have. You see, suppose we have one phenyl group here, another one here, another one here, and this we have OR, right? H plus from the acid will get attacked by the lone pair of this oxygen, and we get what here? We get this O H R and plus. Correct. What happened next? This bond will break and we'll get one carbocation here plus ROH. This is what happened, right? And then some OH minus will attack onto this and we'll get the product. So basically we have to see in which of these given options this carbocation will be stable. That is what the question. Yeah, it is stable, but if there is any possibility, you see, what is the question you see? It is a third degree carbocation is stable. But what is the question? Acidic hydrolysis of ether shown below is fastest when. So any of these given option will stabilize this carbocation or not, that we have to find out. Option C, yes. Because if this any of these phenyl group, if you replace by methoxyphenyl group, which is nothing but this, sorry, methoxyphenyl group is this only, no? What is? We have OCS3 here, right? Now this OCS3 is what? Electron releasing group. So this electron releasing group is obviously stabilize this carbocation. Yes or no? Fine. So first option is not possible because if you place here CS3, that is electron releasing group, that will also stabilize, right? But we have CS3 over there only. Okay. Second option you see, we have a paramethoxyphenyl. Paramethoxyphenyl is this. That will also stabilize this carbocation. Fine. Third option, two phenyl group are replaced. Means we have one more phenyl group here, which is replaced by paramethoxyphenyl group. So in this case, obviously, this carbocation is most stable and the reaction will be fastest. Understood? So this is how you see the question they ask. Okay, JE advanced question. Next one you see. HBr. Tell me the product. What? Phenol and CS3Br. Why so? So actually what happens, first of all, this H plus will come over here, right? And we'll have positive charge onto this. Now to stabilize this oxygen, positive charge on this oxygen, either this bond or this bond will break, right? So when this breaks, this is phenyl cation, which is highly unstable. Fine. So this bond will break and we'll get phenol plus CH3 Br. This is the answer. Understood? So this question was asked in JEE mains. JEE mains. Triple E, which is nothing but JEE mains. Another one you see, BitSat question. It is given that ethanol, C2H5OH. The boiling point of ethanol is 78 degrees Celsius. What is the boiling point of diethyl ether? C2H5O and C2H5O. Options are given: 100, 78, 86, and 34 degrees Celsius. These are the four options. Why it is 34? Why? What is the molecular weight of diethyl ether and ethanol? Yeah. So when boiling point, when molecular mass increases, boiling point also increases, right? When molecular mass increases, boiling point also increases. But here in this diethyl ether, what happens? There is intermolecular hydrogen bonding takes place, right? In diethyl ether, intermolecular. No, sorry. Uh, we have hydrogen bonding in this. No, okay, fine. We have hydrogen bonding in ethanol, right? Intermolecular hydrogen bonding present in ethanol, and because of that, its boiling point decreases. Because of intermolecular hydrogen bonding, boiling point decreases, right? Two things you keep in mind when you have intermolecular hydrogen bonding, boiling point decreases and melting point increases. No, see, when hydrogen bonding, we have two types: intermolecular and intramolecular. So because of intermolecular hydrogen bonding, the boiling point and melting point will be more than the compounds having no hydrogen bonding. Okay, so there is no hydrogen bonding in diethyl ether. Okay, so due to intermolecular hydrogen bonding, ethyl alcohol has has obviously intermolecular hydrogen bonding, and hence its boiling point is more. Correct? Boiling point of ethyl alcohol will be more than diethyl ether. So obviously the boiling point of diethyl ether should be less than this. So answer will be 34. See, all these things you can assume, but if you see, obviously you see one thing. You cannot memorize. Yeah. Logically also it's 34. Like logically also, and you can easily look at the option and say, because you see one thing you keep in mind. Boiling point you cannot memorize of any compound. Fine? Because there are so many compounds. So when they ask you like this question, for one compound the boiling point is given and other one they are calculating it, they are asking you to find it. So obviously it should be either less than this or more than this. Fine. So when you see the option, there are two options which are more than 78 degrees Celsius. So if this is true, this may also be true. Why? Because they know that you cannot memorize boiling point of any molecule. So they won't ask you this question understanding this fact that you know the boiling point of few molecules. No, you cannot memorize the boiling point of any molecules. So they ask you either it is more than or less than. So there are two options which are more than 78 degrees Celsius. So obviously these two are not correct. So answer will be this only. If you do not know anything, then also basic common sense you can apply. You understand what I'm trying to make you understand? Boiling point, again, you see, boiling point you cannot memorize. That the examiner also know. So they won't ask you such questions. If they ask you in this, they will simply give you. Suppose if they'll give you the boiling point of the ethyl ether is, suppose one question if I give you, suppose in this only they give you the boiling point of diethyl ether is 86 degrees Celsius. Okay, then what is the boiling point of ethanol? C2H5OH. And these are the four options given. What will be your answer? Diethyl ether is given 86 degrees Celsius. Ethanol you have to find out, and the options are given. These are the four options. 100, because there is only one option which is more than 86. Leave that fact that whether the boiling point is more than or less than, that you let it be. You just look at the option. There are only one option which is more than 86, and there are two options which is less than 86. So obviously, if the boiling point of C2H5 is less, that is not possible because there are two options here. So only one option is correct, that is 100 degrees Celsius. You understand my point? That they won't ask you, they know this thing that you cannot memorize boiling point of any compound. So whatever value if it is given, your answer will be either less than this or more than this, depending on the option. If only one option is there which is more than the given value, then that will be the answer. If only one option is given which is less than the given value, then that will be the answer. Understood? Okay. Another one you see. This one we have done. And where is this J question? This one you see. CHOH, CS3, P plus Br2 gives you, oh, it's not given here. Then Na gives you X. X you have to find out. Yeah. You want option also? Options is this. We have CH, CH2, CS3, CS3, CS3. Then we have C, CS3, 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 CS3. All these are methyl. Then we have CS3, CS3, CH, CH, CH3, CH3, CH2, CH2, CH3. Last question. This is. Yeah. Why? First of all, we'll get here alkyl halide, right? Bromine will get here, and then Na. So these are Wood's reactions. We'll get two molecules of this will attach. This is the answer. Like you see, like I told you, that organic chemistry, whether you know a reaction or not, with option they'll give you the idea that what could be the answer. I told you this thing. That's why you see when I don't give you an option, you feel like okay, there's you cannot understand what is the product we should have or we could have into this. But when I give you the option, you can understand then okay, this could be the product and the reaction may go like this. And then you actually understand that how the reaction is going on. So that's why organic, you see, it is a bit difficult to memorize all the reactions again. But if you go through once properly, with option, you will have the idea that what is the reaction, what should be the product. Okay, that's why it is a bit easier also at the same time. Okay, anyways, so like we'll wind up the class here only. Okay, so Sunday, I will let you know tomorrow what timing. Okay, Sunday we will be doing metallurgy, right? And then next class biomolecules, and then again half an hour, 40 minutes, we'll solve some questions. Okay. Okay, chalo, you have next class is 7:30. It's already 7, almost 7. Okay. Chalo, take care. Bye bye. Thank you.